Okay, so we've defined data mining and look at data mining processes, and we look at what kind of data can be mined. The next key question we want to ask is what kinds of patterns can be mined. Conceptually, there's two groups of data mining tasks. One is descriptive, another is predictive. So as the name suggests, descriptive data mining task focuses on characterization, finding characteristics of the classes that you're interested in and how those classes compare to other similar classes. Predictive data mining tasks often perform inductions on the current data in order to make predictions in future data. So using existing training examples to create models and then fit future data into this model to make predictions. Those predictions could be predict a class label. It could be predicting numerical values. For example, how much rain we're going to get in this monsoon season. I should mention that descriptive and predictive, I took this more level at a conceptual level because many mining tasks cover both. Very rarely we would only interested in characterization, or we're only interested in prediction. When we mine characteristics, we could use those characteristics to predict, right? Any new data sets fitting this profile, we can predict it to be belonging to this class. Anything that we know it's belonging to this class, we want for a predictive task, we not only want to make prediction, we also want to know why that prediction is correct. So it does also require descriptive and evidence to support your prediction. So those two are not disjoint. So the rest of the slides, we're going to actually look at a number of different patterns that can be mined from a data set, and all those will be covered in this class. So the first set of patterns, types of patterns that can be mined would be class description. So this falls fairly straight to the descriptive mining tasks. But as I mentioned, when you have class description, you can easily use it for prediction tasks as well. So, for example, if you have customers that spend based on budget or spend based on their emotion, or just to spend whatever they have. And you can have those classes you want to know, okay, what's the behavior of budget spenders, impulsive spenders, or big spenders. You can, by looking into the data, perform statistic analysis, or in a data warehousing, using OLAP techniques that we have introduced a few previously. For example, roll up and drilling down, that can help you to generalize or obtain insights into the characteristic of those different groups of spenders or types of customers. We can use those methods to find the characterization properties, or we can use those properties to do comparison, to do discriminative analysis to see how those classes are different. I add an example here as a class to highlight one possibility that when you actually don't have a very simple name to name your class, the example class does not have to be like have a clean class label. You could have a descriptive thing to describe the class. And those handheld devices with 10% increase what caused the increase? I mean, what are the characteristics of those devices that I'm interested to study in order to boost my other devices, the sales of other devices. So this is the first type of patterns we can mine class description. So a lot of methods that you've learned in your statistics class should already be very, very useful to mine class description. You have central tendencies and distributions and all that. Those are all useful for class description mining. Another group of patterns that can be mined are called frequent patterns. There are different types of frequent patterns, and we will cover in this class frequent item set patterns. So those has wide applications in marketing data, basketing, shopping bag analysis, what items being purchased together, for example. Other frequent patterns can be frequent sequence patterns. For example, after you purchased a computer, you might purchase a set of software. So this is sequence pattern mining. And the third group, major ones, is frequent structure pattern. This is used fairly widely in social network analysis, where you can find similar networks, smaller networks, similar sub-networks within a large network. They share similar structures. But in this class, our focus will be on frequent item set patterns. Here are some examples. People buying computer, also buying software. So this is an example of association rule. What it says is people buying computer probably also going to buy software. This probably is characterized by the support and the confidence metrics. Support says among all the customers, 1% of the customers buy both computer and software. So this is the support measure of association rule. Confidence says among all the customers who purchased a computer, 50% of them purchased also a software. So the confidence characterizes the strength of the association from buying this item to also buying another item. Here is another example. So this rule says, this association rule says, if somebody is within this age range and his income or her income is within this range, and then they tend to buy a laptop. So tend to buy. How do we quantify this tend to buy? We use, again, support and confidence. So in this case, support tells us among all the customers we have, people in this age group have this income and purchased a laptop accounts for 2% of all the customers that we have. So 2% of these people have those characteristics, all three elements. The confidence says among all the customers who has this age range, has this income range, have 60% of chance to buy laptop. So 60% of all the people fitting this set of criteria end up buying a laptop. So this is just a very brief introduction to you on association rule. We're going to spend, I think, an entire day entire week study association rules. And support confidence are not the only way to measure the strength or the goodness of association rule. We'll cover those in the future. A very key observation here is association rule does not mine correlation. It does not mine causal relations. Association, correlation, causation are all different. So association rule minus co-occurrence. So those two things just happen to co-occur. And we quantify the strength of the co-occurrence. So for example, here I have association rule, diaper and beer. This is a very famous rule mined very early. I mean, I don't know, 10 years ago probably. In a set of basket analysis, it's actually an interesting story. On a Saturday night, when people buy diaper, they also buy beer. They buy diaper to take care of the baby. When baby is sleeping, they can have some beer, right? So see if we have this support and a confidence. This looks like a pretty strong rule. 75% of people buying diaper also buy beer. Maybe, well, buying diaper is a good indication or increase the chance for people to buy beer. Not really. If we also look into the whole data set, what if buying beer actually occurs 80% among 80% of the customers? Then this rule actually buying diaper actually lower the chance for a person to also buy beer. So by looking at this rule alone, we actually do not know whether there is whether a strong association rule also indicates a strong correlation, or whether buying diaper causing buying beer. We don't know. So I want to emphasize the reason there's many different ways to measure the strength of association rule like this is because association rule mining are not interested in mining rules that has strong correlation, and there is not a way that by looking at the data alone we can actually get the causal relationships. So this is just a caution that I put here when we talk about association rule mining and all different ways to measure the goodness association rule. We will revisit this idea. From your statistics class, you should already know strong correlation does not automatically indicate a causal relation. So if you forgot, you can review this link. Additional patterns that can be mined, classification and regression, those are probably the most commonly seen. You probably already have experience doing classification or regression, numerical regression tasks. So classification is a task where you have training examples. Training examples are labeled with class labels, for example, budget spending customers, impulsive customers, and big spending customers. Those are your class labels. And then you construct a model based on the data that you collected on those customers and try to construct a model that can be used to classify future customers into that three categories or three classes. So this is classification and label prediction. Some additional examples including classify terrorists, classify cars, classify many things. A lot of things, phenomena can be formulated into a classification task. For example, computer vision. How does computer see what's in a picture? We build classification algorithm into computer vision systems. So the system will be given a picture and classify whether this picture contains a car, a sad person, a happy person, or contains a specific or particular person. Okay, so a lot of problems can be formulated as a classification problem. Frequently used methods for classification, we're going to cover a lot of those. I decision trees, naive Bayesian classification, Bayesian network, support vector machines, artificial neural network, rule-based classification, pattern-based classification, association rule pattern, for example. Once you collect lots of association rules, this can be built into a classification, can be used in a classification system. So there is a method called association rule-based classification. Logistic regression. I don't think we're going to cover logistic regression. I think any machine learning class probably already spent a lot of time on logistic regression. Or you probably also learned it in your statistics class. Typical applications, countless. If you pay attention to the news, you can from time to time you heard those stories. And then regression, we talked about classification, and next we're going to talk about regression. Logistic regression predicts class labels. So this is a special case in regression. But here, the regression, when we talk about regression, we talk about numerical regression, where you predict continuous values. For example, how much precipitation we're going to get in a year or in a month. What's the weather going to be today? Or what's going to be, how long this virus is going to last. 2 more years or year and a half. I think we have made that point. The next point to make is some machine learning methods are best for classification or regression tasks. Others can be used for both. For example, artificial neural network can be used for classification and regression. Support vector machines, different variations of support vector machines can be used for both classification and regression tasks. And decision trees. And statistic classes covers a lot of regression. So regression is less of a focus in this class. Our main focus is more of a classification. I just want to make sure I did not miss anything. Yeah. So yet another pattern, a set of patterns can be mined is clusters. It's different from classification or regression tasks, where in cluster analysis, we don't have labels. We have a set of observations. The cluster analysis try to put those observations in groups so that similar observations are closer to each other and different observations are further away from each other. So this is cluster analysis. It's considered a unsupervised learning method because we don't have class label. There's not external input to the knowledge input to the algorithm. The algorithm, by analyzing the distance or the densities of those data points, the algorithm automatically group those observation or data points into clusters. So the principle used in the cluster analysis is maximizing the intra-group similarity and minimizing intergroup similarity. So different group has to be very different, far away, and the elements in or data points in the same group need to be similar, very similar. You cannot, your cluster analysis would fail if the similarity of the items within one group is less than the similarity of the items cross groups, right? And I want to make a point here by saying when we talk about cluster analysis, use the term clusters, clustering analysis, or clustering. We will differentiate those terms. Those are very you can call them synonyms, but they're different from classes. When we use the term classes, we infer there is a label. So avoid using classes when you are talking about clusters. Cluster analysis is an unsupervised method, so no training examples are needed, making cluster analysis a very powerful mining method. There's tons of methods has been created, and they all have strengths and weakness. We're going to cover many methods in this class. So that's cluster analysis. Another related to cluster analysis is outlier analysis. Outlier analysis also can be formulated as a classification task. So outlier analysis try to find data objects that does not comply with the general behavior of the data. So in your data set, most observations are similar, but a few observations are further away from the rest of the data, as if those data were generated through a different mechanism. So those are the outliers. Outliers are of interest because many times we want to identify those. For example, terrorists. In general population, most people will behave in a more moderate way. They will not go extreme, but some people might actually turn out to be violent and harmful to the society. Among large populations, how can we identify those people and help those people? People with other outlier situations, fraud detection, for example. Most people are law-abiding and they don't create false documents and steal money from bank, that kind of thing. So outlier analysis can help detecting credit fraud, many other applications. So a lot of methods has been developed. We're going to cover outlier analysis in this class as well. We can use statistical analysis, we can use classification methods, we can use clustering methods as well. We can use, for example, linear regression. Anything that's far away from the regression line can be declared as an outlier. There's other statistical methods, even the box plot can help you to detect outlier. But those outliers are probably only, well, we'll talk more about those later. So those, I think, are the patterns that we're going to cover in this class. I'm going to end this video and start another video to talk about the rest of the topics.